So while we start talking about absolute value functions and graphs, we're going to look at the most basic function of this family of functions, which we call the parent function. So the parent function for absolute value is y is equal to the absolute value of x. It's the most basic. It doesn't have any transformations. When looking at parent functions, almost all of them go through the origin 0, 0. And if not, then they occur somewhere really close to 0, 0. When we study the exponential function later this year, it'll cross at 0, 1. But there's still a lot of important information going around there. So it's usually a pretty safe bet to start our table somewhere around 0, 0. And in this case, it's no exception. So the points that I'm going to choose to plug in are going to be -2, -1, 0, 1, and 2. And as a reminder of what absolute value is just the distance a number is from 0 on a number line. So when we look at like the absolute value of number -2, -2 is 2 units away from 0. The absolute value of -2 is just 2. So when my input is -2, my output is 2. Absolute value of -1, similarly, -1 is just 1 unit away from 0. There's going to be a 1. The absolute value of 0 is just 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. This provides me with some symmetry in the graph, because whether I plug in -2 or +2, I get out a +2 as my output. And when I look at a graph of this, I'm going to count by ones because my numbers are relatively small. This is how I choose to do a graph. It doesn't have to be how you choose to do a graph. I count each box as 1 whenever possible because it makes my life easier. The x-axis and the y-axis do not have to be the same scale. I like them to be. If you're not precise with your graphs, you will see me leave comments like, doesn't have a scale, your graph needs a scale. What I'm talking about is these numbers, because one box doesn't always have to be 1. So you should have something labeled on the x-axis and the y-axis on what scale you're using. Now, I don't write every single number 1, 2, 3, 4, 5 because it just gets crowded. So I choose to write every other one. All right, and then I go to plot my points, -2 up 2, -1, 1, 0, 0, 1, 1, and 2, 2. These points give me a start. I know in my head I could plug in some more if I wanted them. Like I know 3 is going to give me 3 and 4 is going to give me 4. I could get a little bit more precise with how this is going to look. Same thing for -3 and -4. Didn't really hit my dots there. Let's try that again. And the graph of an absolute value is going to look like a V. When we were graphing parabolas, those look like U's, and they don't have a constant rate of change. Here for a absolute value, this is like a portion of a line and a portion of a line. So they'll be nice and straight. My vertex is right there at the origin, 0, 0. The vertex of a graph is the point where the graph changes direction. So if I write down the definition of an absolute value, the absolute value is the distance a number is from 0. Okay, so we know that the absolute value of, if I say the absolute value of x is equal to 3, what could x be? What value can I plug into the absolute value brackets to get out 3? 3 and -3, right? So x is 3 and is -3, yeah? Ooh. So if we take that concept, which doesn't seem too tough, and we generalize it, instead of y is equal to the, instead of 3 is equal to the absolute value of x, I have y is equal to the absolute value of x. So I know that this value of x in here could either be positive y or negative y. If I have negative y is equal to x, but I want to solve for y, I can either multiply or divide both sides by negative. So divide by -1, divide by -1. And that gives me y is equal to negative x. We agree that we can kind of move the negative. So when we're talking about what this looks like, these equations, y equals x and y equals negative x, part of them are available, are apparent in this graph because y equals x is the line that has a positive slope that goes up to the right. And y equals negative x is the line that has a negative slope that goes down to the right. Now, in this case, we're talking about the absolute value, so we're talking about the positive right here. So I actually just get this graph here for the y is equal to the absolute value of x. But they're parts of lines. So we really only use one format when we're looking at absolute value functions. And I'm going to talk about how can I extract information from this in order to graph. So we're looking at equations that are in the form y is equal to a times the absolute value of mx plus b and absolute value plus c. And there's multiple ways you can find the information. I'm going to show you two. One of them is like less procedural, and the other one is like more memorizing. So I kind of have this purple method and like this, I don't know what color that is, fuchsia method. So to find the x-coordinate of the vertex, I can either think of this as taking whatever inside the absolute value set equal to 0 and solve for x, then taking that and plugging it in to get y. Or I can use kind of this formula if you prefer to memorize formulas. It's kind of whatever works for you. All right, so to start graphing, I want to find the vertex. I typically use kind of a combination of these two methods. I'm going to start off with the purple method because it is more conceptual, which I think is a good thing. So what I'm going to do is I'm going to take what's inside the absolute value brackets. I'm going to set it equal to 0. So I have x minus 3 is equal to 0. And then I solve for x. Then I take that value of x, I plug it in to find y. Always. Anytime you're given an x value and you want to know the whole coordinate, you just plug in x to find y. So I would get y is equal to 3 minus, absolute value of 3 minus 3 plus 2. I'm going to pause there, give you a few seconds. That might have been a little fast. Yep, make sure you scan and fill out the form first, and then wipe it down when you return. Okay. You could have also just used this other kind of method right here, where I would take the opposite of this and put it over the number in front of x, which would be 1. So you'd get 3 over 1, same thing. Also, as you do this, hopefully you can come up with the pattern that the y coordinate is just always going to be c. If I set this equal to 0 and find a value for x, and then plug that value back in, I'm going to get 0. So you're just going to get whatever's left here for your vertex. All right, this gives me enough information to start graphing. The next thing to look at, which I know is like kind of way up in the corner now, is the slope of the pieces of the graph are going to be plus or minus a times m. You're not going to see an m value very often, but it's going to come up here and there. Okay. Let me scroll back, zoom back out. Maybe. Oh, that's too far. So when I'm talking a, I'm talking about the number in front of the absolute value. When I'm talking about m is the number in front of x. Well, I don't have either in this case, which means that they're each going to just be 1. So when I'm looking at my slope, I have plus or minus 1 times 1, which is just 1. So I'm going to use that to count. Now, be aware, this is positive, so it's going to open up. So from here, I'm going to go up 1, over 1, up 1, over 1, up 1, over 1. and I get a graph like this. All right, how do you feel? What questions do you have? What can I help with? Yes.
How did you find the other plot points again? Like, I get you found the vertex, but how did you get the other ones again?
So I just used my slope like I would when graphing a line. So are you good on how I got this number?
Not really. Like, how do you know it was that and it wasn't go right to each one instead?
Okay, so the slope that I wrote up here on like my information area is plus or minus a times m. It looks like am. It looks like word, but it's a times m. Where a is the number in front of the absolute value and m is the number in front of x. So when I look at this here, I wrote these in afterwards, but what is the number in front of the absolute value? 1. Let me actually erase those and I'll rewrite them in a different spot. Sometimes I change my original problem and then it gets confusing. Okay, so if the slope, I need a times m. The a value here is going to be automatically 1. The m value here is automatically 1. So I have 1 times 1. If you remember slope, when you think back to like math 1 and math 2, slope is always written as a fraction if you'd like. And the top number is what I rise and the bottom number is what I run. So from here, if I'm talking about a positive slope, this is up 1, over 1, up 1, over 1, up 1, over 1. And then same thing in the opposite direction. So up 1, left 1, up 1, left 1, that's my negative slope. Cool? Awesome. Great. I love it. Any other questions that I can answer? I wrote rum instead of run. That's not the right word. Okay. That's good. We're going to do another one. Okay. So again, you can use kind of either one of these methods of thought. If you like to memorize, you're like, oh, I'd just rather memorize this kind of like shortcut. Cool. I never remember it, honestly. So I just typically use to take this and set it equal to 0. So I have 3x plus 12 is equal to 0. And I find x from there. It's really the same work. One's just kind of a shortcut. I'm better at remembering concepts than I am at remembering equations. you can think of finding the y value in a couple of different ways. I could take -4 and I can plug it back in. After you do enough of these, you're going to recognize that the y coordinate is going to be whatever I add or subtract outside. So if I take -4 and I plug this in, that just turns into 0. That's how I got it. -0 is 0. And then plus some number out here, well, it's just 0. So my vertex is going to be -4, 0. Now I've done quite a bit of graphing absolute value equations, so I know in my head, I have like an idea of where this graph's going to lie. If you don't have the forethought, that's not a problem. It just might be that I draw a graph and I go like, oh, this graph doesn't fit on this coordinate plane. You need to adjust. So you got to change your scale or you got to extend it. I know that by looking at this, I'm going to need some more room over here, so I'm just making that area of the coordinate plane bigger. So my vertex is at -4, 2. 1, 2, 3, 4. I'm sorry, -4, 0. Oh, I didn't do my graph right. Wah, wah, wah. Erase, redo. Because this graph is going to open down, not up. You can always adjust it by just changing your scale on the y-axis instead of erasing the whole thing. But all right, so I have a negative in front, and the negative means that this is going to open down, and I need to go ahead and find the slope. So when I look at slope, A, which is the number in front, right, is just going to be a -1 or a 1. Doesn't matter because it's going to be plus or minus either way. And then N is 3. So I get a slope of plus and minus 3. Now, if you prefer to write that as a fraction, you can always do 3 over 1. I need to make sure this opens down. So I'm going to go down 3 over 1, down 3 over 1. Yes.
How do you know you're going down?
Because of the negative in front. Same way I would with a parabola. If it's negative, it's automatically going to be a reflection across the x-axis. Let's make a note in case you go back to your notes and you're like, wait, how did I do that? So the negative means I'm going to open down. Good. Awesome. Cool. Other questions? Yep. Go ahead. Good? All right. Do you feel okay about this? We did 2 examples only. They're similar to parabolas, just a different shape, a couple different ideas, but that feels good? Okay. On Google Classroom, you will see this scanned in there. It says 1.0D worksheets, and it's got 8 questions circled for you to do. 3 of them are just matching, and then 5 of them are graphing. So you'll need to do these on a separate piece of paper. You will have time to finish this today. I'm not going to collect it today, so I'm not going to talk about it until Wednesday. But you will have time to finish this. We have lots of time left in the period. A couple of things to remember. Last week, a lot of people finished this worksheet in class, but it's not technically due until today. So if you have it, please come up and put it in this paper box right here so that I give you credit for it. I am going to put, yeah. Can I get that worksheet? Yes. I am going to put a list